It's my great pleasure to present my article. My article's title is Robust Design of Machine Translation System Based on Convolutional Neural Network. I will present this article by introducing the abstract first. Aiming at the problem of low-load robustness coefficiency and recovery robustness coefficiency of machine translation system in different scenarios and working conditions, which leads to poor robustness. Convolutional neural network is used to optimize the robustness of machine translation system. The operation process of the machine translation system is stimulated through the steps of corpus pre-processing according to the composition and working principle of the machine translation system, word alignment processing, and phrase extraction. Obtain the load data of the machine translation system, and with the support of building a convolutional neural network model, according to the measurement results of the vulnerability of the machine translation system, use the convolutional neural network to determine the system load scheduling amount. The robust controller is selected as the executive element to complete the robust design of the machine translation system. The experimental results show that the machine translation system designed by the optimization method has higher load robustness coefficient and recovery robustness coefficient under different scenarios and operating conditions, which confirms that the robustness design effect of the optimized machine translation system is better. The article is divided into 4 parts. The first part is introduction. The second part, the robustness design of machine translation system. The third part is the experiment and analysis of robust design effect test. And the last part is the conclusion. In the introduction part, we all agree translation is the main method of equivalent transmission of information in different languages, and this process is particularly important. Machine translation technology plays an increasingly important role in promoting political, economic, and cultural exchanges with the rapid development of economic globalization and internet. Traditional manual translation consumes a lot of financial and human resources and inefficient. The translation results can be obtained efficiently and quickly by using computers, and it is particularly important to replace human translation in the field of professional translation. This paper applies the convolutional neural network to optimization design of the robustness of the machine translation system in order to improve the robustness of the machine translation system. The analysis and experiment in this article are mainly from these 2 parts. The second part of my article is the robustness design of machine translation system. There are 6 sections in this part. First, stimulating the running process of the machine translation. Second, obtaining machine translation system load data. Third, building a convolutional neural network model. Fourth, measuring machine translation system vulnerability. Fifth, using convolutional neural network to determine system load scheduling amount. The last one is implementing robust design of machine translation system. At present, there are many kinds of machine translation systems which have been well applied in teaching and international communication, and they have good development prospects. However, the system operation is unstable in the practical application of machine translation system due to the low robustness of the system. The robustness of the machine translation system is designed according to its working principle in order to improve the running robustness of machine translation system and thus improve the running stability. The whole process of machine translation can be divided into the following three parts: model translation, model training, parameter feature optimization, and translation decoding. The overall structure of the machine translation system is shown in Figure 1. Model training includes basic processing steps and training language models and sequencing models. The parameter feature tuning stage uses the existing bilingual corpus to continuously update the feature weights of the model to make it optimal. The translation and decoding module translates the source sentence through the model and feature weights learned during model training and parameter feature tuning. The operation process of the machine translation system is shown in Figure 2. This is the flowchart of the operation of the machine translation system. It is necessary to convert the corpus into a regular form that meets the module input requirements before the machine translation system runs the translation program. A pre-processing process is required to irregular corpus. Corpus pre-processing can be explained from the following three aspects, namely word segmentation and special vocabulary processing. Word segmentation is a basic process flow natural for natural language processing problems, but the quality of word segmentation directly affects the subsequent processing process and has a crucial impact on the final result. The word segmentation process of the initial translated word is shown in Figure 3. Part 3 of the article is the experiment analysis of robust design effect test. A number of different types of machine translation systems are selected as the research objects in order to test the design effect of the robust design method of machine translation system based on convolutional neural network, and the stability of the analysis system is tested under different operating environments and operating conditions. Compared with the traditional system robust design method, the application advantage of the optimal design method is reflected. This part can be divided into 4 sections. The first one is configure the research object of machine translation system. And then the second one is to input the operating parameters of the convolutional neural network. And the third section is to set the test index of robust design effect. After that is the experimental test process and result analysis. Multiple SBP is used as a test tool. The translation test data in the system translation speed are sentences collected through the website. The test concurrency is stimulated by multi-threading, and the training corpus is used in collecting 2 million sentences in a laboratory. The benchmark translation model takes the gated convolutional neural network (LSTM) as the base through the encoder and decoder, and the attention mechanism is used in the connection between the decoder and the encoder. The traditional robust design method based on the direct state space theory and the robust design method based on the disturbance observer are set as the comparison method of the experiment in the system test experiments. The robustness of the machine translation system is optimized by the design method, and the robustness design is completed. This experiment tests the robustness of different systems from 2 aspects: the running scenarios and operating conditions of the machine translation system. Machine translation tasks is run under different attack environments, counts the running data of the system, and obtains the evaluation test results of the system robustness and the different operating scenarios through the calculation of Formula 15. It can be seen from Figure 9 that the higher the attack intensity in the system operating environment, the lower the system robustness coefficient. The robust design method of the convolutional neural network-based machine translation system applying the optimal design has higher load robustness coefficients and recovery robustness coefficients is compared with the traditional robust design method. That is, the robustness design effect is better. This is because the load instability coefficient of the machine translation system is set as the vulnerability measurement index to measure the vulnerability of the machine translation system. The different operating conditions of the machine translation system are control the number of translation tasks of the system. Observe the changes of the system robustness coefficient, and the final test results are shown in Figure 10. It can be seen from Figure 10 that there is a negative correlation between the number of translation tasks executed by the system and the system robustness coefficient. Through vertical comparison, it is found that the average value of the empty system load robustness coefficient of the comparison method is 0.37 and 0.28. The average value of the empty system load robustness coefficient of the optimization design method is 0.66, and the value of the optimization design is 0.29 and 0.38 higher than that of the comparison method. This proves that the robust design method of machine translation system based on convolutional neural network has better robustness design effect. This is because the neural network is introduced into the system, through which the load scheduling amount of the system is determined, and the robust controller is designed. The robustness is improved through the combination of various aspects. Then comes the conclusion part. The machine translation system realizes the intelligent transformation of translation work. This technology is used in translation work, can innovate the retrieval technology of cross-language information in my country, and it has industrial application value and social value. The operation stability of the machine translation system in different scenarios and operating conditions is effectively improved through the design and application of the robustness design method of the MT system based on the convolutional neural network, and the application value of the machine translation system in the translation work is improved. This is the outline of my article. I hope it is of interest. Thank you. If you have any questions, you can contact me at any time by sending me emails. Thank you.